Let's begin with architecture. So when we say Postgres, you know about Postgres now. It's one of the hybrid database fundamentally meant for maintaining data which can be compatible for both RDBMS as well as NoSQL database. So when it comes to architecture, we can consider two levels of architecture. So one is with respect to database. We can consider database architecture. Database system architecture. So we can consider database as well as system architecture. So here we are very much familiar with architecture of our RDBMS, particularly database, Oracle database. Here, as we proceed, so we'll come to know that what is the difference between architecture of Postgres as well as Oracle database. So when we consider database architecture, so as I'm explaining earlier, Postgres is having good architectural components. So we can go for various components which helps us to manage the database in an effective way, as well as so we can also leverage the underlying systems resources, and it can become a good database to leverage the underlying resources. So we'll first let us look into database related architecture. So then we'll move on to system architecture also as we progress in the course. So when it comes to database, what is a database is in general? What is a database? It is a place where data is stored. Okay, it's a place where data is stored. That is what. Okay, so collection of information, a place where data is stored. So it is nothing but set of objects that will host the data. So in a way, we can call it as database is a place where data is stored in organized way. Okay, stored in organized way. So if any software has to become popular or if it is to become efficient, we need to consider two aspects actually with respect to the softwares. So one is the storage, the other is processing. Okay, so second one is processing. So we have to consider both storage as well as processing. So here storage wise it must be efficient. It must be efficient, and processing wise it must be effective. So means the data should be organized in a well organized manner so that okay, we can fetch the data easily, faster. Okay, that is what the efficiency is. Processing means how fast okay, you're going to fetch that information from the place it is being stored. So with respect to this, okay, if we take a simple example, so if we organize our books in bookshelf, or if we organize our files in our system in an organized way, hierarchical way, based on the our own criteria, so we can use that files or books easier way. So because of this, we must be efficient in storing those files or books. Okay, so and we can use it easily. We can use it easily. So with respect to storage, when it comes to Postgres, so we got a database. When it comes to Postgres, we got database. So which is efficient. Postgres wise, database is efficient. So when we say database, in general, okay, we know it is a place where data is stored, but actually if you take, it is nothing but set of files and also objects. Physically, it is set of files, and logically it is objects in which data is stored. So database alone can't be used for any purpose. So for using that, okay, we need instance. Okay, so if you take any softwares for that matter, the processing will happen only in memory, and the processor will do that job. Any processing will happen only in memory. So even with Postgres also it will happen in memory. So here in that case we got a component called as instance. So we can also call it as service. Instance of service is one more component which we can use it for our purpose. When we say instance of service is nothing but memory structures. Okay, so very similar to Oracle database, it has got good memory structures which is used for specific purposes. Because of this, it is efficient. Okay, and it has got background processors which does the job. Okay, so periodically, because you know that any processing that is done in memory should be synchronized to the disk or files periodically. Okay, so in that case, we got memory structures and background processors. So because of this, it is effective. So it has got effectiveness because we got various memory structures which is used for specific purposes, and whatever the changes that is going to take place or modification that is going to happen in memory will be synchronized to the set of files available in disk by the background process. Because of this, the processing is more effective. Okay, so means it is going to satisfy the fundamentals of softwares. So storage wise, it has got good storage structures. Files wise, objects wise, we can organize the data well. Processing wise, it has got very good architecture with respect to instance, or we can also call it a service. So which is a combination of memory and background processors. Because of this, it is effective. So when we say database alone can't perform anything. So we should actually call it as database server. So database server is nothing but database plus instance. Okay, database plus instance is our service actually. So with respect to this, let us look into which are those components part of our Postgres database and instance or service. Now let us see the first difference comparing with Oracle database. So when we say Postgres database, PostgreSQL, okay, I'll call it as Postgres itself because previously it was Postgres, and even okay, if you take any multiple components, we'll use Postgres name within PostgreSQL itself. So Postgres database, when we say that, okay, it is nothing but DB server. Okay, database server. So when we say database server, here we'll not have one database. We'll not have one database. So it is not, but basically it is a set of databases. So in fact, okay, we can call it as cluster of databases. So here in Postgres environment, it is not just one database. So we'll have multiple databases. Okay, we'll have multiple databases. Multiple databases are there. We'll see which are those databases. So here, if you take one side, okay, so you can consider a specific type of databases. We can consider them as default databases. We can consider them as default databases. Here we have got default databases. So here, and okay, the other side we got non-default databases. So these are non-default databases. Now when it comes to databases, it is nothing but cluster of databases. So this is your cluster. In a simple way, what is cluster in general? What is cluster in general? We normally use this system. What is meant by cluster? What is a cluster is? Okay, so fine, Riaz. Okay, so Rakesh, we can put it in the other way. It is not just more than one instance. So okay, so fine, Feroz, collection of servers. So in a way, we can call as group of cluster, group of related resources, group of related resources. Here in our case, we got group of databases, a group of databases. Say group of Fox is also called as cluster. Fox is also called as cluster. So when we say cluster, it is nothing but a group of related resources. In our case, is a group of databases. It is a group of database. We'll not have one database. So we'll have two types of databases. One set is the one set we got here is, so for example, there's a by default, there's a database by name Postgres to which we connect always. So whenever we say connect to PostgreSQL database, we are going to connect to Postgres database. Is a default database. So similar to that, okay, we got other default databases like template 0, template 1 kind of databases, which we won't discuss in detail. Why they are required also will come to know. Whenever we say as users we connect, we are connecting to Postgres database. And For applications or users, you create separate databases. So for example, there's a database by name DataSphere if we are created. So there may be a database by name OurDB. Okay, so AppDB. You can give any name for your databases, and those are non-default databases. They are non-default databases. So basically, they are group of databases. So then, how to use them? How to use them? So we got instance. We got instance. We can also call it a service. Instance is a memory structures and background process. That is what we know. So is used by client to work with the database. Suppose if you got a client, okay, we'll see how client processes will happen. Okay, we got a client. So from my client machine, so you can connect to database. Okay, you can't connect directly. You can't connect directly. So because database can't be used directly, because what is database is, in our example, you know, is set of files. We can't access files directly using editors. It can be text editors or special type of editors. We can't use them. Whenever you want to use database, so you have to do that through instance itself. So you have to connect to an instance. Through instance, you have to work with the database. So which of the database it can be? It can be either default database, or it can be even a non-default database also. So if client has to connect, so must always connect to, so client has to always connect to instance to work with the database. Which database? Either it can be default database like Postgres, or it can be non-default database, some like you can give our DB, DataSphere DB, AppDB, whatever the name you have given. So you'll be able to connect through one instance itself. Okay, so when we say database, as we are discussing, you know that it is two components basically. So when we say database, physically, logically, okay, so physically it is set of files. Okay, it is set of files. Logically it is objects. Physically it is set of files. Logically it is object. We can, because of this, we can call as logical structure and physical structure. So here you can consider physical structure. So you got physical structure and you'll have logical structure. So physical structure is nothing but set of files. Logical structure is nothing but objects. Okay, here. So then when you consider instance, so you know that it is nothing but memory structures and background processes. Okay, so memory structures and background processes. BG process. So called as BGP. So with BG process. So this is what, okay, so is a simple structure of our database. So you know the first difference itself here, unlike Oracle database, we're going to work with multiple databases, cluster of databases, which is taken care by through one single instance. So here, which are the databases which are available by default or called as default databases, and we can also create our own databases to accommodate data. So they are called as non-default databases. And we are going to use only one instance, means same set of processor and memory to work with the databases. Now, what is that common thing that will be stored in default database and non-default database? Okay, is it non-default database depends on any of the default database? So except creation, so in any other layer, so they will not depend on the default databases. So if you consider this with Oracle database, we got multi-tenant database. Is it same as multi-tenant database? No. Each database is an independent database, individual database, which is confined within itself. So means if you take a database, you can treat as if it is only one database available. So users will be made to work with that particular database itself. So will not depend on any of the default databases when we are working with our own databases. So if you consider multi-tenant database, there will be dependency on the container databases when you go for pluggable databases. Here, that is not the case actually. So each database is an independent database. It doesn't depend with other database for any of the structures or contents or objects. But all will depend on one thing. So any client has to work with any of the database should use the same instance to work with the database. So this is about a simple structure of Postgres DB server. The DB server contains two components, database plus instance. Postgres has got a different type of working. So when we say cluster of databases, it is multiple databases. Okay, so and structure wise, there are set of files, and I'm saying set of files, not data files, set of files and process. Okay, so logical wise objects actually. It's a cluster of database. So default databases wise, we got Postgres. So we'll have other databases also like template 0, template 1. Non-default databases you can create with whichever the name you need. Datasphere DB, our DB, app DB, new DB. You give a name whichever you feel relevant to your applications. And whenever client has to work, they can't work directly. So they can't connect and work directly to database. So it must be avoided. So they have to connect and work with database through instance only. Either they connect to default database or non-default databases. So they have to connect through instance only. And for that, they will use a platform called as PSQL. This is somewhat similar to SQL Plus in Oracle database. PSQL is a platform to work with databases. There we could use PSQL commands and PSQL statements to work with databases. So when it comes to storage of these, so each database, so we'll have a different type of mechanism to store the data. So for that we have to influence, which we'll see later part. Okay, later part. Now let us look into the processing, how will happen. So here in briefly I've explained client must connect through instance to work with any database. It can be default database something like Postgres, or it can be a database something like Datasphere or Datasphere DB, whichever the name you have given. You have to connect through instance itself. And you know that, okay. So why we have to connect through instances? Because the data will be processed in instance itself. Client will use PSQL to connect and work with the database. So with respect to that, how that processing will happen? See, we got cluster of databases, means we have got group of databases within which, okay, so we have stored the relevant data. And being users, we may connect through any connect to any database. Default, we always connect to Postgres database by default. Now, when we consider the processing wise, so client, okay, so client might go for various types of tools available, and they can perform the activities. Client might use a browser. Okay, so to connect apps, they can use tools, they can use utilities also. So some like PSQL, for example. So we might use a utility called as PSQL to connect and work with the database. And whenever a service is initialized, okay, so a session has to be initialized. So a client process is used actually. Client process is used, and will connect to database server where a PG process is allocated. Who's going to allocate? I'll explain the architecture. Processes architecture I'll explain. Now client process is going to connect to a PG process. There's a mechanism, listening mechanism, initializing the PG process and connecting is there. So that is the first step. Means whenever client want to connect, so client process started on the client system will be connected to a PG process. So after that, the communication is direct between CP and PG, client process and PG process. PG means you can take it as simple as Postgres. So it's somewhat similar to server process in Oracle database environment, and that is what we call it as. So session is established. A session is established. In that session, user can give any amount of requests. So whenever the request is given, so it first checks the memory itself whether the data is available. If not available, it will go to the disk. Okay, means we'll get the data from database. It can be any database, depending on to which database you are connected. It can be from any database. So it is going to fetch that information into memory. So always you know that processing will happen only in memory. So PG process gets that data. Who's going to get the data on behalf of client processes? On behalf of client processes, PG process is going to get from database and places it in memory. So that is the second step of fetching the data. IO will happen. The processing is done here based on the client request. What are the requests given? It can be select request or it can be changes requests. So DML. So based on that, the processing will happen and the data will be fetched and processed and will be given back to client actually. Okay, so same channel will work. PG process will interact with client process. So suppose if the user has asked for select, okay, so select star from table where user is equal to Ram, example, or customer is equal to Ram. So it is row number 6 actually. Each row will have its own ID and that it will have data. So that data is there in basically in disk initially. It has to be brought to memory. It has to be brought to memory. That's why whenever a client gives a request after the initial session is established, okay, whenever the client gives a request, PG process on behalf of client process will get the data from database, places it in memory, process it, and it gives the output to client actually. This is what interaction will happen. Now where processing is happening in instance. Where data is present is there in database. If you consider in that way, both database and instance. So you know that both put together is our database server will have same name. So both are having same name. So database server means database plus instance. Say database name is also Postgres, instance name is also Postgres. I'm talking about default database to which we connect directly. If you want to store your application user specific objects in separate database, you can do that actually. So, and always, as I explained earlier, so when we say database is nothing but physical structure and it will have logical structure. Logical structure are nothing but objects. Same way, when we say instance, is memory structures and background processors. So, memory structures, whenever we say this data is brought to memory, it is processed in a specific memory depending on the request. Okay, depending on the request. So, if it is modification request, it is going to use an area. If it is a select request, it is going to use an area. And if it is a sorting operation, it has to use a different area, memory area. So, like this, okay, if it is a structural changes, it will use a different memory area. You got various memory areas to process a specific type of request. Because of this, it is efficient. So as if you can take not only with database architecture, even with instance architecture, so Postgres is good. Okay, Postgres is good. So somewhat similar to when we take a standard residence, so which we live. Okay, so we may have 2 BHK or 3 BHK residence. So we'll have different parts. So we can take it as veranda, portico, veranda, so drawing hall, so bedrooms, puja room, kitchen. Why we separate them is so that we can optimally utilize that space and it is not cluttered actually. Same way here, it uses different memory structures for processing it. And when it comes to database, it's straightforward. Physical structure and logical structure objects. So I think many of you attended my Oracle database course. So there I start with physical structure and logical structure. If you can recall, but here I start with instance. Okay, I start with instance because instance architecture is important. Database wise, it is straightforward actually. Straightforward, but there are some differences. Let us understand instance architecture first thoroughly, then we can move on to database architecture also. Ultimately, we should know both. And the way they function is what important for us. Because Postgres behaves slightly different in architecture comparing with Oracle databases. Or for that matter, if you take all our standard RDBMS, Postgres is a different type of processing actually. So this is about the way the data will be processed. So client process connecting to PG process, we'll see later. So session is established. In a session, they can perform any number of transactions. You know that yesterday I was explaining about Postgres, we got transaction concept. What is transaction is? From the point we make the change to the point, it is committed or rolled back is a transaction, is supported here. So for that entire duration of session, it can perform any number of transactions. All those transactions are processed by the same PG process. If data is available already in memory, it uses it. If not available, it gets from database. IO will happen. 2 and 3 is IO. get the data from database. So 4 is processing. It has to process, then it gives the fifth step is it gives the result to the client actually. Okay, so now part of our processing. So client, we got client. So in which client process is started is important. We might use a browser-based tool or applications or some tools, command line interface tools, utilities, for example, PSQL, for example. So whenever we initialize that in a server from which we are connecting to the database server, I'm talking about physical server of database server. So then that client process is started on client's machine. So what is that responsibility activities of client process? Okay, so it might be a browser based access, it can be application based access, it can be tools, or it can be utilities. So from the server or system from which you are initializing them, so you'll have a client process. We can shortly call it as CP. So this is what, okay, so here, so this is our CP actually. So our CP client process is responsible for performing certain activities. So first thing is used for front end facilities, client facilities. So it might be any type of tools as I'm explaining, which we'll see also a browser based tool or a application, or it can be tools that we use it for administration purpose. Utilities we might use it for working with database, maybe as administrators and even as users, whichever it is. So we'll have a CP process, client process, which is a front end facility. So means an interface for users to work with database. So it can be GUI based applications, it can be GUI based applications, text based applications, and even web services also. See, today's environment, we got various types of applications and they are being enhanced. So, and most of them they are getting integrated with AI and machine learning, ML, artificial intelligence and machine learning. So, and they may use different languages to work with that. If it is any type of language they are using, the front end application can be a command line interface related tool or GUI related tool, graphical user interface tool. So can be used with Postgres. Even then, that case client process is started. So and whenever they want to interact with the server, so TCP is used. So client will connect to server using TCP protocol. Gives a request to server. What type of request? It can be DML request, change. It can be query request, so reading data, or it can be structural changes, DDLs. So, or it can be object related administrative details like creating an index or rebuilding indexes. Any of these requests can be given. So here why I'm stressing all these operations is, unlike Oracle database, so architecture, here they are processing different type of memories actually. And the way they are processed also quite different, which we keep understanding as we progress. So statements are issued. For all this, we're going to use statements. Various types of statements are used, and actions are performed using tools and utilities. Okay, so one such tool is, as we are discussing, PSQL. Okay, so somewhat similar to our SQL plus, SQL Star Plus. Here we got PSQL. So multiple users. Okay, so generally, so this is, we have to quote that. So it is a multi-user who can access database concurrently. So when concurrency comes into picture, so there's a very important consideration. Will be important consideration. What is that? Important consideration is integrity of the data. Means if I ask a simple question, can two users updates or modify same set of record? Not possible. So as if two-person reserving same railway seat, example. Okay, so it's not possible. Or if you take real-time example wise, if you visit a bank and if you are depositing money, okay, which we don't do normally nowadays, if you are depositing money and if you're given a check to your friend who is there with you only again, So, and you want to withdraw that money, so by using the check leaf that you have given. So you know that you have deposited money now. If friend is standing behind you, if he gives that check to the teller, so you will not get money because the money deposited must be authorized now. Authorized now. So means there is a mechanism here. Unless authorized, means authorizer is there who has to authorize it, means a commit has to take place back end kind of thing. Only after that, that amount will be reflected in your account so that okay, your friend can withdraw. That's why okay, if you have done this, okay, so transaction, whenever you visit a branch and if you deposit money and if your friend is withdrawing money immediately, so they will say wait for a few minutes, maybe a couple of minutes or 5 minutes, something like that. Reason is it has to be authorized, it has to be committed. So it means when concurrent operations are happening, depending on the domain, I gave an example of banking. It can be different in different environment. So depending on the domain, so the concurrency should be taken care and integrity should be maintained. So when we say concurrency, concurrently users using database is important. Okay, in that case, what will happen? They must be using. So they should not affect the integrity of the data. What is integrity of the data is? So two users should not modify same record. Only after one releases, the other should use it. Otherwise, what will happen if two persons reserve same seat, railway seat, so or flight seat, whichever it is. So it is very difficult actually. So here we can consider concurrency is important. Does Postgres has got to handle all these things? Yes, it is there. It is good in that also. So this is about client process. This is a front-end facility. You can use GUI-based tools or command line interface tools, some utilities. Okay, administrative purposes also we can use. And whenever client connects to server, it is going to use TCP for that purpose. A request will be given to the server and the statements are used to process those requests. It can be DML requests, queries, or DDL requests. We are going to use statements. Which statement? SQL statements itself. And so these activities are performed using tools, utilities. One such is PSQL, for example. So I'm introducing PSQL because we're going to use that extensively. Later part we will see other tools also, which we are going to use it for our administration purposes. But PSQL is not just for administration; it's also for user usage. Okay, so multiple users can concurrently access the database. So even though they are accessing concurrently, data integrity is taken care. So this is about client process importance. So now we know that okay, client process. What is that it is going to do? That is what we have discussed. Client process is a front end facility to work with the database. So here a PG process has to be started, or client process connects to server means it is interacting with PG process. How this PG process is started? Who's going to start this? Okay, so with PG process one on behalf of client process is going to work with the database. So PG process is part of your instance, which will be connecting to database, performs an IO, connecting to database with the data which is there in database. So we can't use database directly. That is what you know that we can't use them directly because we can't use text editors or any kind of editors work with the data of our Postgres database. So it should be done through always through instance. Whenever we do through instance, client process will interact with PG process. How that is allocated? How that is allocated? Okay, so this is a architecture. There's an architecture. So if you consider this, client process, we know that about client process now. So you can use any of the facilities available, browser applications, command line GUI applications, or even utilities. Okay, so whichever you're going to use, client will use client process. So whenever we say CP, client process, so it has to interact with which process? PG process. What is PG process? Postgres. We'll have multiple PG process for every client session. For every same user or different user, secondary. Same user or different user for every client session. So there's a PG process started and the communication is direct between client process and PG process to which is been attached. Who's going to do that? So whenever client connects to server, so there's a process, master process, which is responsible for doing this activity called as postmaster. Okay, so it's called as postmaster. So it has got as of now we can take it has got dual role, two roles it will do, two things it will do. Okay, two things it will do. First thing is, first step is what? Client gives a request, means who is going to listen to the request, connection request on behalf of Postgres or Postgres database server. He is postmaster. Means postmaster will act as a listener. Will act as a listener. So whenever client connects to database server, Postgres database server, so means nothing but instance, postmaster comes into picture. So it listen the connection request of client process. Is going to spawn a PG process. Spawn means what? Start. Okay, so that is the second step that is done by PG process. It's going to do that job actually. It's going to spawn a process. Spawn means start. Forking also starting. You can simple we can call it start. Basically we call it spawn. Spawn means start. What it starts? A PG process is started for a client process. Then it connects that PG process to the client process. So now a session is established. That is what we call a session is. It means client is connecting to PG process. Who will do that? Postmaster will do that. What is the first responsibility of postmaster is? It will act as a listener. Okay, so then it is going to start a PG process whenever the connection requests are given, and that PG process is attached to the client process. Now onwards, the communication direct between the client process and the PG process. What are the requests that thereafter are given? So what are the requests thereafter are given will be between the client and client and PG process. What client will do? Gives request. What PG process will do? Give a response. What kind of request? It can be any type of request. We call it as transaction. So it can be basically it can be a statement, a DDL statement. So like creating a table or creating an index. So DML, making changes to the existing data, loading data. So or it can be transactions related activities, commit also, rollback. So all this will be given. We call them as transactions. So and PG process is one which is going to interact with database to process the request of a client. Client can't connect directly; it has to connect through instance. Means when we say instance, PG process, postmaster will start that. So that is what is the first responsibility of postmaster? Will act as a listener, listens for the incoming connection request, starts a PG process for the incoming connection request, and attaches that to the incoming connection request given by the client. Client process is connected to PG process. What is the second responsibility? Postmaster is responsible for starting other background processes and manage them. Means it is the head of your instance processes. So head of your processes. So postmaster is the master. So means it is the first process of your Postgres actually. First process. Which is the first process in operating system? Which is the first process that starts in operating system? I'm talking about first process. So, okay, so or you can call it daemon also. First process or daemon in operating system. Init. Init is mother of all processes in operating system. Init will initialize first. Then it will spawn or will start other process. Similar to that, which is the mother process or the first process of Postgres is postmaster. Okay, and it is going to spawn other background processes. Okay, it's going to start the other background process. So that is the responsibility, second responsibility of postmaster. Okay, so will act as a listener, is the master of your instance. So we'll start all the background processes and we'll keep monitoring them. So this is the job of postmaster, which is one of the important, very important component actually. So now we know about client. So let us move on to server part now. So server part, I have introduced postmaster. Postmaster is the first process that is started You start all other background processes after that. So mother of all your Postgres related background processor is Postmaster. Okay, so now when we consider client has to connect always to server, APG process started. Now you know that it is done by Postmaster. The part of our instance got two components. One is memory structures, one is background processes. So memory structures is important. Okay, so let us understand memory structures first. Then we'll move on to background processes. So part of memory structures, I'll introduce background processes also. We'll see both. So, but here we'll focus for memory structures. Part of that, okay, we'll learn background processes. In fact, okay, we'll learn background processes first actually. Now it comes to memory in Postgres, we can call as shared memory. For shared memory, in that, okay, we got two important components. One is shared buffer, the other is wall buffer. So shared memory is equivalent to shared pool in RDBMS, means in Oracle database. Shared buffer is something like your DB buffer, database cache buffer. Wall buffer is equivalent to log buffer. So these two are important components. There are a lot of differences. Okay, just comparison as I'm giving. So shared buffer and wall buffer, they're going to behave different way, but they are for specific purposes. In simple way, shared buffer is for accessing your data. Wall buffer is to write your changes before you make a change to the data of your, okay, before making any change to the data of your shared buffer, the change, whatever the change you are doing, must be written to wall buffer. Which is first? Is it going to write the changes or it is going to make the changes? First is writing changes, next is making changes. Write change to wall buffer, then make the change is the way it will function internally. So now when we say shared buffer and wall buffer, they are for specific purposes. So and they got their own characteristics. We'll see buffer space later. Okay, buffer space later. So part of that, okay, we'll also start learning about. So when we consider shared memory within that shared buffer, so when we look into the architecture, here we got client, so we got shared buffer. So as of now, okay, so shared buffer is the place where the changes will happen, the data changes will happen. So data can be used, modified in shared buffer. So and who is going to do that is client is going to do that activity. So client will do that activity. So client will connect to shared buffer. So and you know that when a client connects, here we'll have a PG process on behalf of that to process the request. When a client connects, a PG process is available, part of your instance, to take care of the request given by the client process. Now, what are the changes it is going to do? That before that, I will write the changes to wall buffer also. I'll explain more about wall buffer. So, shared buffer is the area in which the changes to the data will happen. Any changes to the data will happen in shared buffer itself. Now, whenever these changes are done, so those changes, we will bring this data from, okay, so this data initially will be there in database. Who's going to bring that from database to memory? Okay, so fine. So here we got the same data is there available here initially. So is brought to memory. So we'll do that is PG process itself will do that. PG process itself will do that. Same PG process which has to modify the data. Okay, we'll bring that data to memory. But that should be written back to database now. It has to be written back to database. So periodically, it has to be written to database periodically. So what is that periodicity? We'll see. This data will be written here. From shared buffer, it will be written. That is done by BG writer. So I'm introducing the first background process, BG writer. You can call it as background writer. This is a background writer responsible for doing this activity. Okay, what are the data that is there in memory? Respective blocks. If this is the block or a page memory set of blocks, actually will be written to disk. Okay, will be written to disk. So whatever the data brought by process is written back by BG writer. So BG writer is responsible for writing the content of shared buffer to database. When it will do that? When it is going to do that? So one event, which will say one event now is whenever a checkpoint takes place. Whenever a checkpoint takes place. So checkpoint is the event which makes BG writer write the content to database. So the respective data which is there in shared buffer modified will be written to the respective area of your database. So BG writer will do that whenever a checkpoint takes place. So there are many events in which checkpoint will take place. One is checkpoint threshold. How to define that? Okay, we'll see later. So there will be a threshold which we're going to define when that data should be written to database. We call it as checkpoint threshold. So it means after a certain amount of shared buffer is modified, so it should be written to disk. So how to define the checkpoint threshold is we got parameters. So we'll see as I said, I'll explain that at a later part. As of now, you can keep it simple. What are the data that is being modified in shared buffer, which was brought by PG process on behalf of client process, modified in shared buffer. Before modifying, it writes the changes to wall buffer. So then those changes will keep happening after certain time. So it will not write for every change done, it will not write, or every commit it will not write. It is going to write it periodically. That periodicity one is checkpoint. Okay, so checkpoint. So checkpoint will happen for various reasons. One is checkpoint threshold. PG writer, background writer is responsible for doing that activity. So writing from shared buffer to respective area of your database. So I'm saying respective area, it is not data file. Okay, so it's not single data file. We'll see. Architecture wise, it is different actually. We'll see that later. So this is about simple information about BG writer. Okay, so next let us look into the next process. So now you know that okay, we got client process. Client want to connect to work with database. So we got PG process. Client gives request to server so that okay, PG process is started. So you know the postmaster will do that, and now it has to make the changes to the data available in shared buffer. So if the data is not there, it has to bring from database. But before making any changes to the data, so PG process will write that change to wall buffer. What is wall is write ahead log. Write ahead log means before making change. Write ahead means what? Before making change, logging will happen. That's what it is called as write ahead. So is also called as transaction log file. So in Oracle database wise, we call it as a redo log file. Okay, so read log buffer. Write means redo log. So now we got a buffer for that. Okay, we got a buffer for it. So we'll see more about okay, shared buffer, wall buffer later. So what are the changes that client has to do through the PG process is first return to wall buffer by same PG process which has to make the changes, then it will make the change. So third step is it's going to make the change. It can be only one change or it can be 1 lakh changes. Doesn't matter. Any number of changes. First write the change to wall buffer, then make the change. Make the change. Now the changes are written to wall buffer. Why they should be written to wall buffer is because you know that in shared buffer the data will not be maintained only for the duration of your transaction. It is going to maintain for longer duration. Even after commit, data will be there. So, and that data will be returned back to database by BG writer, which we know that whenever checkpoint takes place. But till then, changes will not be there in wall buffer because wall buffer is normally smaller. So that will be written periodically to wall file. So wall file is not wall files here, wall file. So means we got a read head log file to which the data is written. What is that information written here is 1 lakh changes that has to be done by PG process. Those changes are written in the form of changes to wall file. The same 1 lakh changes are written. When it is written, so whenever a commit occurs. The moment commit takes place, what are the content available in buffer will be written, or even if it is filled also will be written. Okay, anyway, so commit occurs, contents are written to wall file from wall buffer. Who will do that is important here. That is done by wall writer, write head log writer. When it will do, whenever a commit occurs, whenever a commit occurs. The other is it will also do before checkpoint, means before BG writer writes the content of shared buffer to database, wall writer will write the content of wall buffer to wall files. So first event is commit. You should consider commit first event, but before checkpoint also it is written. So this is second event also. But first one is very important. Means before BG writer writes, wall writer will also write. Or whenever commit happens, even then the contents are written to wall file. So which is maintained. Wall file usage is different. We'll see that later. Anyway, it is going to maintain the changes which is written to wall buffer by clients will be maintained in wall file. So statements are issued in a session. How many transactions we can perform? We can perform any number of transactions. It can be in this case transaction 1, 2, 3, 4. Concurrently also can be done by maybe by same user or different user. So what is the transaction is from the point you do DML to the point you commit or rollback is a commit. Okay, so sorry, it is a transaction. Okay, so if you take user wise, from the point the changes started by user to the point commit, submit or cancel happens. So being users, what we do, we start doing some activity. In the end, okay, if we feel if it is okay, we will submit. Otherwise, we cancel it. So submit is commit, cancel is rollback. So DML change is nothing but DML. So submit is your commit, cancel is rollback. But in Postgres, by default, when we use PSQL, default is auto commit. Even your DMS are auto committed by default if you are using PSQL. You should take care of this actually. Okay, you should be aware of this. So commit. We got one more consideration with respect to some more DDL changes. So about commit and DDL changes, I'll explain that in when we are doing practicals actually. So we're creating objects, I'll explain that. So means whenever a transaction happens, so statements are used in a session. We can perform any number of transactions. When a transaction happens, CP process using PG process will make changes to the data. But before making changes to the data, it has to write the content to wall buffer. So and changes will be done after that. First is writing changes to wall buffer, then making changes. Then wall buffer contents are written periodically to wall file as periodically as commit occurs or before checkpoint. Means before BG writer writes, even then it will write. So users may commit or auto commit might also happen depending on the tool you are using. So first process is BG writer, background writer, responsible for writing the contents of shared buffer to database. So second process is wall writer, responsible for writing the wall buffer content to wall file. So now we know about two important background processes of our Postgres database instance, BGWriter and WAL-Writer. So now let us see two more. Okay, so two more. Database can be in two modes actually. One is no archive mode, then is archive mode. Default is no archive mode. So we can place database to archive mode for various reasons. One is for having hot, to take hot backups, or to perform point-time recovery, or even for having standbys, hot standbys. So we need the database to be in archive mode. Okay, so when we say archive mode, our objective is what? We want to copy the content of WAL file, whichever is written from WAL buffer, content of WAL file to arclog files. So again, here there is a difference in the way arclog files are created, which are explained in arclog files wise. Okay, so as of now, we take WAL file behavior is also different, archive files behavior is also different. So that's why I'm not starting with the database here. So okay, I mentioned the initial itself. So I've started with the instance because database architecture is different in Postgres compared to Oracle or so even with other RDBMSs actually. So as of now, what is WAL file? Is a file in which changes are written. Archive files, so we'll have multiple types of archive files will be created. Who's going to do that? Is archiver will do it. Only if database in arclog mode. Okay, and if you enable database for arclog mode, so archiver is initialized and it is responsibility is what? To copy the content of WAL file to arclog file. So in fact, here we should just call it as WAL file. So what is WAL file means? Write ahead log file. Write ahead means what? Before making change, write. Initially the changes are written to WAL buffer. I'll explain architecture again further. WAL-Writer will write to WAL file. Now in content in WAL file they are overwritten. How many WAL files will have, how it is used, we'll see later. Anyway, any changes written to WAL file is overwritten. Now we want to preserve that for longer duration so that it is useful for us to use it for hot backups or point-time recoveries, hot standbys. Means for our purpose of recoveries basically, we need changes also. In that case, we must enable database to arclog mode. Once you enable the database to arclog mode, archiver is initialized, is responsible for copying the WAL file content into arclog files. So there will be different type of arclog files depending on the stage of your archiving. So we'll see that later. Anyway, we can call it as archive files of what? WAL. Write ahead log files archived contents is your WAL file contents. Who's going to do that? Archiver will do that. When it will do, we'll see that later because you should understand WAL file functionality because of that. So as of now, we take that who is responsible for creating archive file is of WAL file is archiver will do that. Now, so you know that whenever we got a client connects to server means PG process is started. So you know that it will start the it will give a issue a statement modification. For example, it has to modify the data now. It has to modify the data, but before modifying, write the change. So here in our example, I'm taking. So it is going to write the change number. It is going to make a change 916. But before making this change, that change is written to WAL buffer. So 916 is written to WAL buffer. So I'm taking change number actually. Example wise, I'm taking change number. So means before writing the changes to the shared buffer content, so it is going to write that changes to WAL buffer. Now change will happen after that. So this is what our normal functionality. Okay, normal functionality. Now commit occurs, the change will return to WAL buffer. So now previously what happened? So checkpoint will keep happening. Checkpoint will keep happening. So checkpoint means what? Contents of your shared buffer is written to respective location of your database. When it will happen? Whenever checkpoint takes place. Whenever checkpoint takes place. So checkpoint is an event. Okay, checkpoint is an event. When it will happen is now I'm giving one. Okay, so shortly we'll see few more. So whenever checkpoint threshold reaches, checkpoint threshold reaches, checkpoint will take place. BGWriter will do its job. Write the shared buffer content to a respective area of your database. Before to that, wall writer has written. So anyway, wall writer will keep writing whenever commit occurs, but also write before checkpoint, means before BG writer writes, it will write. Till that point, data is returned to database. Okay, this is happening. So it happened previously at 800 example wise. I'm taking example wise. Previously it happened at 800. So then at 840. So this you can take it a change number. Then at 885. Then 915. So this you can take it as change numbers. So then that changes are written, and once checkpoint takes place at 800, so changes are written, but before to that, okay, so are part of that activity, so the content is also written. Means what it means, till 800 data is there in database. Till 800 data is there in database. So only after 800 we need changes. That's why you're going to mark checkpointing position in your file actually. Checkpointing position in your file. Who will do that is checkpointer will do that. Checkpointer will do that. Checkpointer is a process responsible for updating the checkpoint information with your files. Like it is going to make a mark. Now next checkpoint to express at what value? Change number 840. So means what are the changes available here? Periodically change done is written, but data changes are there in memory till 840. That is also written to database by BG writer. Now checkpointer will maintain that. So 840. So next checkpoint express 885. 885. So now that is up to changes are anyway written and data is also written. After data is written, is going to maintain checkpoint position. Then 915 is the next checkpoint express. After that, in our example, so we have taken only one change, 916, which is there, change is there in memory and change is done in shared buffer. Probably because of commit, this 916 may be written to wall file also, that might be available, but after that, okay, it may be any changes. Till this data is there. Now whenever crash happens, these changes are not required. These changes are not required, but they are archived. They are archived. So in case of crash recovery, it has to apply in this example, it has to apply only 916, because till 917, till 915, data itself is written to database. How does system comes to know that till 915 the data is written is checkpointer is going to make a mark there. Checkpointing position. Checkpointing position. Data previous to that change. Okay, so will be data previous to that change will be there in database. So no need to apply these changes. Data after that is there in memory because these changes is maintained, which is used for crash recovery. Checkpointer ensures that. So you're going to maintain the position of your checkpointing so that till that point data is there in database. Only after that changes has to be applied. So this is the job of checkpointer. When it will do that is whenever checkpoint takes place. In what situation checkpoint will take place, we'll see that. Okay, so I'll explain that next. So this is what. So now I'm getting a lot of queries here. Is this change similar to SCN number in Oracle? Yes, true. System change number. So this is system change number. Is this clear? So when it comes to shared buffer is the area in which the change of the data will happen. It can be for any amount of data, so changes will happen. But before making that change to the data, what are the changes statements that are requested will be written to wall buffer. From wall buffer, whenever a commit occurs or before checkpoint takes place or part of checkpoint, okay, before writing happens, data is written to wall file. BG writer will write the data to database to the respective area of your data. So we call a checkpoint event. So and after that checkpoint process comes into picture. So what it is going to do is it's going to synchronize the checkpoint information with all the files. So here it is going to maintain till what point the latest checkpoint has taken place. In this example, we are taking that 915. Okay, 915. So after that, any number of changes happen. So here we are taking only one change. 916 is there in shared buffer. Further changes also will be there in shared buffer, but that data is written to wall buffer, and from there it is written to wall file periodically. So now the checkpoint event happens. Okay, checkpoint is going to maintain. With this, what will happen? Whenever there is a crash, the amount of data to be applied will be known after this checkpoint position. So the data has to be applied. That is what will come to know. So for that, checkpoint is going to perform the activity. Now, when checkpoint will take place? When checkpoint will take place? So as we are discussing now, what are the changes that is going to happen to the data in shared buffer? So in our case, previous checkpoint took place as 915. Okay, so 915 that is maintained. Okay, that is being updated. So is there in maintained by checkpointer. So when that checkpointer will do these activities, after BG writer writes the content to respective data area from your shared buffer. But BG writer before to that, wall writer has written the changes to wall file. So means all files are synchronized here. So and checkpoint is going to maintain the checkpoint information. So that will happen whenever a backup starts. Whenever you start taking backup, or whenever you end the backup. When you start backup and end backup. So checkpoint will take place. Or even whenever you create a new database. See, in Postgres environment, so we initialize database. We don't create database. We initialize that. Default databases are created. Non-default databases we want to create depending on our application requirement. So whenever you create such type of databases, so even then checkpoint will take place. Whenever a threshold happens, we can call as dirty page threshold. Means what is the amount of data that should be modified so that checkpoint will take place. We can call it as checkpoint threshold or dirty page threshold. So we have to do a settings for that. Whenever that threshold happens, then also the data is returned. And there is one more event when shared buffer is full. Then also checkpoint will take place, but we should not allow that to be filled. But before to that only, we must ensure that the checkpoint takes place. Otherwise, it becomes a performance issue. Now, whenever this happens, okay, so checkpointer is going to maintain the information. Part of the activity, so BG writer will write the shared buffer content to respective area of your database. Before to that, wall writer will write the content to or wall file from wall buffer. After that, checkpoint is going to maintain the checkpointing information. Now, whenever the data from shared buffer is written to the respective data area, so it is going to follow LRU algorithm. LRU algorithm, least recently used algorithm. Okay, what is the least recently used algorithm is whichever the data which is not used recently will be written first, assuming that the data that might be used again, because this whichever the data that is used frequently will be written to will be used maintained in the memory, then it is not right in the end actually. And here it is SLRU. In Postgres environment, it is going to follow SLRU. S means simple is LRU. It would perform based on SLRU is going to maintain the information. Means LRU list it will maintain. Least recently used item will be written first to the disk actually. Once it is written, that area has become clean so that it can be overwritten by any other new operations, new transactions. That is the case actually. Now, from shared buffer, BG writer writes whenever checkpoint takes place. Whenever after that, checkpointer will maintain the checkpointing information about the point at which the checkpoint has taken place. After that, changes are also again written to wall buffer file, but data is not written to database. Still there is in shared buffer itself. Any crash recovery, so shared buffer contents will be recovered because that is lost, will be recovered using the wall file contents. Now, for certain reasons, we have to maintain the wall file contents in the form of archive. Okay, we have to maintain the form of archive, so we can do that actually. So in a simple way, so shared buffer is a location in which changes will take place. Wall buffer is the place in which changes are written. So if you take PG process 1 is making the changes to the data that you are giving. So your statement is so accessing or modifying row number 6 to 8, for example, row number 6 to 8. So which is brought to memory. Okay, is brought to memory and is going to make it as one transaction, one change itself. Get the data from database if not available. So and whenever checkpoint takes place, data is written by background writer to respective data area. Okay, so PG process which writes the changes to wall buffer, that changes are written periodically to wall file by wall writer. So and checkpoint takes place whenever checkpoint event occurs. So whenever checkpoint event occurs, checkpoint takes place. So this is what we have learned. Now further to this, so after checkpoint, data is not required. Okay, data is not required. It can be overwritten. Okay, it can be overwritten. In WAL file, data can be overwritten. Okay, so whenever it overwrites the data, so then it is going to get the space. But here our requirement is we're going to place our database to archive mode. So default is no archive mode. No archive mode means changes will not be preserved for longer duration. Now, if you want to preserve it, what is the need for you to preserve? So you want to go for backups, live backups or hot backups. You want to maintain hot standby. Okay, so for that, those reasons you might need changes to be preserved in the form of archive log files. Okay, so you want to maintain them in the form of archive log files, archive WAL files, or WAL archive files. You can call it by any name. But now how that content are written? So who's going to write is archiver will write. From where it write? It write from WAL file. But here we got only one WAL file. We'll have only one WAL file. Within that, it is going to make it as segment actually. Means it is going to make them portions. So how many portions is depends on your WAL file actually. So there's no hard and thumb rule. Okay, we have got only 2 or 3 or something like that. It depends on your WAL file size. So a segment will be made internally, and segment wise it is going to copy. Archiver will copy the content of WAL file segment wise. So for example, segment number 1, okay, is written. Now it is writing to segment number 2. Is writing to segment number 2. So now when WAL writer is writing to segment number 2, so segment number 1 is copied. One is copied by archiver into archive file. So here the way archive log files are created is quite different. As of now, you take archive log file is created using a segment, and now once segment 2 is also filled, so now WAL writer will start writing to WAL. Okay, so segment 3. Once segment 3 is filled, assume that okay, we can have only 3 segments here. Segment 3 is filled, so it comes back to first segment and it starts overwriting. But before overwriting, it ensures that archiver has copied the content to archive destination. Okay, so your ultimate file is created, archive log file is created. So without archiver copying, the content is still active, cannot be overwritten. Okay, so WAL writer will not be able to overwrite it. So because here we'll have only one file, one WAL file, which is content is overwritten periodically. Okay, and because of this, archiving also should take place. When archive happens, the content can be overwritten now. So the old content which are there in memory can be overwritten. This can be overwritten. So this is about archiver will doing the job actually. So what is the advantage of maintaining the archive files is the changes that you have done is preserved for longer duration, and you can use it for your useful purpose, like point in time recovery, for example. So this is about archiver. BG writer responsible for writing shared buffer content to respective area of your database. WAL writer is responsible for writing the WAL buffer content into WAL file. Checkpointer is responsible for maintaining the checkpointing information. So after checkpoint event is triggered, BG writer writes, but before BG writer, WAL writer writes. After that, checkpointer maintains the information. Archiver is optional. If you enable database archive mode, archiver is created. Okay, so next let us look into just two important background processes. One is logger, one is stats collector. So one is system logger. See, what is system log is nothing but somewhat similar to your alert log file. System is nothing but your instance which is working. So it has to write the information to a file about its performance actually, means how it is performing. If it is doing an activity, if it is encountering an issue. Okay, so all this will be written to a log file. We call it a system log file. So there is a process for that logger. Logger itself will take care of that logging information. Now we want to do performance tuning. So where we got a flexibility to tune database, in case of Postgres also. For that, we have to get the statistics. There is a dedicated process for that called a stats collector. So what are the statistics it is going to collect is for performance tuning. So two processes. We got few more as and when we come across a specific feature. So I'll explain them. Okay, so with those topic itself. So for example, application wise, we got processors. Vacuum wise, we got processors. So whenever we come across such type of topics, okay, I'll explain them because they need further explanation, because what they do is specific to that feature actually. Okay, specific to the feature. So related to architecture, but specific to feature. Because of this, we'll discuss with that specific feature itself. Application related or vacuum related or any other component related background processes which are started, maintained. Again, Postgres is one of the processes which will maintain. So we'll look into them as we progress into those topics actually. So let us move on to memory structures. So first one, we'll start with shared memory. We'll start with shared memory. So in shared memory, we got two important components. One is shared buffer, other one is wall buffer. So when we say shared buffer, so name itself says that is a buffer that is shared by whom? All users, all databases. Because for multiple databases, cluster of databases, we got only one instance. So, and same memory area processors has to be shared. See, process wise they do their job, that is secondary. But memory wise we have to use it. Means whenever client gives a request, client process is started, CP. You know that it is a front end. You might use GUI tool or you might use a command line interface tool, utilities also. So on behalf of client process, postmaster will spawn, create a PG process, attaches that to the client process. Communication thereafter is between the client process and PG process. PG process has to modify the data based on the request given by the client process. But before modifying any, it writes to wall buffer. That is, we'll see later. So now it has to write. So whenever it has to write the data, that data must exist in your shared buffer. If it does not available, same PG process which has to use that data will bring that data from database, places it in memory and will modify it. But before modifying, as usual, it writes to wall buffer. Changes will be written. Then it is going to make the change. Once the change happens to the shared buffer area, it is dirtied. What is dirty buffer is an area that has been modified, committed or it to be committed. Still is there in shared buffer, that is not there in database. So PG process will do that changes. We call as dirty buffer. Now that will happen in which memory? Shared buffer. How to define the size of shared buffer? Shared underscore buffer. In configuration file, we're going to define this. So I'm introducing the first parameter, shared buffers. So default value is 32 MB. Default value is 32 MB. So suppose if your RAM is 1 GB or more, see, you may be surprised to see 1 GB, because okay, all these days we work with most of your Oracle database administrators or DB2 SQL Server. They are big bulky databases. So we go for more memory. Here when we say 1 GB RAM or memory, okay, so in that it is going to use 25%. Okay, it's going to use 25%. So because unlike traditional RDBMSs, Postgres can work with commodity servers. So servers available with organizations or smaller servers customized to your requirement. It can work with that. Because of this, we don't expect a bigger memory. So 1 GB means it is 25% of that RAM actually. Default size is 32 MB. Okay, so if you want to go for bigger one, you can also change that shared buffer. But unlike Oracle, so it is a static component. What is static component? If I want to modify the value, so I have to modify this and I have to restart the service. I have to restart the service so that the change will come into effect. Now, shared buffer is size is defined by shared underscore buffers configuration parameter. Okay, so which is a static component. Default size is 32 MB. So if your RAM size is more than 1 GB, it is 25% of your RAM, and it follows LRU algorithm. SLRU. S means simple LRU. You can call it as LRU also, but Postgres specifically calls it as simple LRU. It follows a simple LRU. Least recently dirtied buffers is written to disks. What is a buffer is? What is the difference between buffer and cache? Memory. Memory means cache. What is the difference between buffer and cache? See, technically, if you take our architecture wise, software wise, there's a difference. Okay, if you take normally, they're same actually. Buffer or memory or RAM, okay, whatever you call it, is same. But when we say buffer, buffer is a, you can take it as a compartment. Okay, compartment of your Postgres in shared buffer area. So that compartment can be used for storing something and retrieving that and modifying it actually. So that is okay. So internally it is going to use the dirty area. So in the form of pages, we call them as pages. Means group of your memory will be divided internally in the form of OS sizes. Instead of that, it is going to group them actually Postgres wise, and it will be called as a page, and it is going to dirty it actually. Means it is going to modify it. Modified shared buffer is called as dirtied buffer, dirty page. So will be returned to disk by bgrater whenever a checkpoint takes place. Whenever the checkpoint takes place. So when checkpoint takes place, one event you know now is whenever a dirty buffer threshold happens, which we can define. So then checkpoint also will take place. So shared buffer, static component, size by the parameter, shared underscore buffers, default size 32 MB. If your memory is greater than 1 GB, it can be 25% of your RAM size, memory size. And whenever PG process modifies the data after writing the change to wall buffer, modifies the data, modified buffers are called as dirty buffers. Dirty, and those dirty buffers are written to disks by bgrater whenever checkpoint takes place. So based on LRU algorithm, simple LRU algorithm, SLRU algorithm. So this is about shared buffer. So similar to shared buffer, the next important component is wall buffer. Okay, wall buffer. Client process connected to a PG process by your postmaster. Session is established. Client process can give any amount of requests in the form of statements. Can be for any type of request. So now PG process based on the request given by the client process, so as to modify the data in the shared buffer. But before modifying, it has to write the change to wall buffer. So first it will do write the changes, then it is going to make the change. Then it is going to make the change. So that is the consideration. So now where that change is written is the wall buffer. Wall buffer is static in nature. If you define the size, you can go for wall underscore buffers. Default size is 64K only, smallest component. Okay, because so even if you keep it bigger, also is not useful because commits will keep happening. So and because of this, so when the commit occurs, that content that is there can be overwritten. So because of this, keeping it big is not useful. Default is 64K. You can resize it by changing the wall underscore buffers. But whenever you do this change, as wall buffer is a static component, you have to restart your service. So whatever the content available in wall buffer written by PG process will be written to wall file into a segment which is active at that point of time by wall writer. So whenever commit occurs or whenever a checkpoint occurs, means before BG writer writes, wall writer will write the contents. Even if BG writer is not writing, periodically wall writer will keep writing depending on commits that is going to happen. So and here portion of your wall file is used, which you can call as a segment. So this is what again wall buffer is. Is a static component, size by the parameter wall underscore buffers. We're going to set this in a configuration file. We'll see which is a configuration file, where it will be available. And it is 64K size by default. Keeping it big is not useful. So contents of wall buffer will be written as frequently as commit occurs, where commit will keep happening in the Postgres environment. So, and you have got auto commit option also. So these are about two most important components of shared memory. Now let us move on to the next memory area. This is shared memory. Shared means what? Shared memory, shared buffer. So shared memory is something like for all databases, for all users. Shared area. So shared buffer wise, wall buffer wise, all users for any database they are working with will be able to use these components. Okay, so multiple users can use this shared buffer. Now let us move on to two components. Okay, two components. One is work memory. Okay, so work memory. So the other one is maintenance work memory. So they are for two different purposes. You can call it as work area, maintenance work area. So now what is work area? What is work area? Is an area in which your transactions will do sorting kind of operations. Whenever they want to work with the content of your object, okay, like sorting, distinct values finding, okay, so ordering by, for all this it is going to use with this work area. So work area, how to define that is work memory. Okay, work memory. So if you are defined as default 1 MB, okay, so then it is going to use that 1 MB, and this is by a specific session only. Okay, so a session will use this area. If you want to define a bigger one, okay, so because you are doing bigger sorting operation, for example, you can define it through work_mem. Work_mem is a configuration parameter which you can use it to set the work area memory. So which is of 10 MB, for example, you'll use that 10 MB for every work area. Okay, work area is nothing but an area in which we can work with the contents, working with the contents of the objects. Content of the objects, we're going to work with it. So like sort operations, order by operations, finding distinct values, okay, grouping the data. So if you are going for joins, okay, so if you are using hashing, so then all this it needs work area. So somewhat similar to PGA, but in PGA we got only one PGA, but here it is work area is one. The other one is, okay, so we got maintenance work area. Okay, so maintenance work memory or maintenance work area. So basically this is working with the structure of the object. Structure of the object. Default size is 16 MB. Work area size is 1 MB. Maintenance work area size is 16 MB because it has to work with the structure of the object. Means obviously it is a bulky transaction. So for example, if you create an index, okay, so if you create an index, it is going to use maintenance work area for creating index. Why it has to use maintenance area? Because your data in tables is not in sorted manner. It has to sort it now. It has to sort it now. So for that, it is going to use maintenance work area. So that's why it is bigger in size. If you are going to use alter table command and add a column with the default value, okay, when you add a default value, what happens? It has to add the value to each and every row. Okay, where already part of your table with a default value. It can be any default value. It has to add. It can be a Boolean value. It has to add that value. So in that case, while adding a column to your table, which is a structural change, so it is going to use maintenance work area. So, and if you add a constraint, okay, so along with your column, even then it is going to use your work area because of a constraint. For example, primary key, it has to build an index. So for that, it is going to use maintenance work area. If you add a foreign key, where it has to refer, okay, and it has to use it, even then it is going to use maintenance work area. Means whenever you work with the structure of the object, then you're going to use maintenance work area. So means we got two work areas. One is work area or work memory. Then is maintenance work memory. Now let us again look into our DB server. So when we say DB server, we got database, symbolically specifying Postgres database, and we'll have an instance. You know that database base is a cluster of databases. Multiple databases are available. By default, we got one database called as Postgres. Is a database to which we connect always. Whenever we say we connect to Postgres, we are connecting to Postgres database. Okay, so when we say database is a physical structure and logical structure. Physical structure wise, we got a set of files. Logical structure wise, we have objects. So with respect to that, let us look into the first component, data file. So here, so whenever we go for a database, so we'll not have a file for it actually. Instead of that, it is a path. Instead of that, for a database, okay, we'll have a path. For example, Postgres is one database. Okay, under PostgreSQL, we'll have many databases. Some of them they are default databases. Okay, we'll have default databases, and even we'll have non-default databases, whichever the way you create them. Okay, depending on that, you might have any number. Okay, so for example, one such default database is Postgres, and we are going to have a path for this. So in this path, the files are created for what objects that you're going to create. So similar to that, any databases you got. Okay, we got template 0 database, template 1 database, which are created by default whenever we initialize Postgres, and they'll be using their own specific paths actually. Similar to that, when we create a database, so even that database also will use a path by default. And whenever we create any database, okay, so we'll have component called as OID, object ID. For database also we'll have object ID. Even for Postgres we'll have object ID. For template also we'll have object ID, and template 1 also will have object ID. And for example, in our case, our DB, I'm assuming that object ID is 15555. So which can be a path actually. Now, when we consider what is that path for our database files is, so you can take your user home directory in which you install the software. So under that, okay, you'll have version directory, in our case version 12. So we'll have data directory, in that a directory by name data. So then you'll have base. So under that, so there will be a directory by OID. So for example, OID is, if you take for our DB, 15555 is the object ID. It will be there with that actually, that name. So here okay, you'll have with that name 15555 or whichever the ID you got. So this is your username directory. Under that, version directory. Okay, under that, data directory. Under that, base directory. Under that, it is going to create a subdirectory by OID of a database. So in a way, we can call it as PG path. Okay, so PG path, or you can also call it as within database directory locations. So it will give the path actually. So this is your PG path directory. This is your PG path directory. Under that, you'll have a directory by name base. Base means base for your database files. OID. So whatever the object ID of your database, okay, it will be there. So for example, Postgres can be 13.825. So this can be template one, template 0 is 1, for example. So template 1 is, so it will take 13,824, one value lesser than Postgres actually. What is object IDs for any structure that is created in Postgres? We keep giving unique OID, object ID. With that name, it will be there. So means in this case, if we take this path is YSPG user is the path. Under that version directory 12 is our version. Under that data directory. So for data, within this there are many directories. One such is base directory, base for your database. Within that okay, have OID. So this is the path now. This is the path in which files will be stored. Means it is not just one file. Okay, it's not just one file. So it is a set of files actually, set of files. So whenever we say specify for Postgres, location of Postgres is some location, in that okay, files will be created for your objects, for which of the objects you create. This is the primary difference. If you take traditionally, if you take Oracle database, is database itself is logical unit. For that we'll have a table space. For table space you can have one or more files. Okay, one or more files. So and in that file contents are stored. But here if you consider the, whenever we say file, it is not actually a file, it is a path in which files of your database is maintained. Which for what files are created is for your structures. Files will be created. Okay, we are not going to define the path and name of the file. There is no name for the file. It depends on the object that you want to create. Only path is defined, only location is defined. That's your data file. So it's not a single data file. It is multiple data files in a specific location of your database. Now, one difference in Postgres comparing with our particularly with Oracle database. So for a table space, we go for a file path and file name, which is part of your database. Or if you take traditionally, databases will have files if you take any other databases. But here Postgres, when we say database, is a location, is not file actually. Is a location in which multiple files will be there available, part of your objects. Now let us look into the next file, WAL file. So we know that whenever a client process connects to Postgres, a PG process is started. Now clients want to do a change. First it will write the change, then it will make the change. So this is the behavior, we know that. Now what are the changes written to WAL buffer? WAL buffer. So will be written to WAL file periodically. Okay, periodically. So whenever commit occurs, for example, first it writes to segment number 1. Once that is filled, it will start writing to segment number 2. Once that is also filled, it goes to segment number 3. Then it will come back to segment number 1 and it starts overwriting. It starts overwriting. So this will be the cycle actually. So now WAL writer will write the content to database, but before writing, okay, so WAL writer will write the content to WAL file before this. Okay, so whenever a commit occurs, if checkpoint takes place, even BG process also will write the, or BG writer also will write the data to databases actually. First WAL writer will write, then BG writer will write. Now when it comes to WAL file, so we'll have only one WAL file. Within that segments are created. With that segments are created. So currently it is using this segment. So once this is filled, it will start moving using the next segment. So previous segments are archived. They are archived. Only if they are archived, okay, when it comes back, it can overwrite it. So keeping it big, okay, so depending on requirement is up to you to decide actually. So every segment is created as a separate archive file. Segment wise, it is going to copy from your WAL file. Only after the archive file is created, because your database is in archive mode, so WAL file content can be overwritten by WAL writer. Otherwise, it has to wait, which will be a performance issue. So this is about WAL file. A file write ahead log file means before making the changes to the actual data, the change that you want to do, not data, change the statement you can take in simple statement that you want to show should be written to wall buffer. From wall buffer, it is written to wall file, will be maintained. So, and will be overwritten whenever your process comes back, wall writer comes back to write to the previous segment actually. Now, when it comes to database, we can be there in two modes: no archive mode and archive mode. Default is no archive mode. Because of this, wall files are not archived. Suppose if you enable database to archive mode, we'll discuss that in administration. Once you enable, so now onwards it start creating multiple archive files, means archive files. That depends on many other factors. One such is the segment size, it matters. Now, whenever contents are from wall buffer is written to wall file. So previous segment, so in our case segment number 1, okay, is available now. So in segment number 2 is being used. So this content is archived now. See, whenever you say archived, there it has got a behavior. First, it is going to create a file by name .ready. So the file naming convention is different. We'll see that later. So .ready. Ready means it is copying. It is copying. So means it is copying the contents here. So your archiver is copying. Archive file is getting created. Once it copies, so it will change this to done actually. So done. File contents are written and the contents are written into the file. So and it is been said that okay, so what are the content was there is been completely written. So star is your file name .ready means it is becoming ready. Star.done means it has been completed. So two status you can find. So in our architecture destination, you can see these two files. If you are in archive mode, we keep creating these files for maintaining the information, because whenever it copies, it is going to create a ready file. Then after that, it is going to make it as a done file. This will keep happening. Now we want to go for custom configurations. Initially, when we do implementation, we'll go for default configuration, but later we have to do customization, and it is mandatory kind of thing actually, because as when we start getting into the advanced configurations, we have to do settings actually. Because of this, configuration file becomes mandatory, almost mandatory. As of now, okay, we'll go for default configuration. So rather than calling it as parameter file, it is better to call it as configuration file, because we're going to do the configuration settings. So the configuration file is available under PG data, the same location in which base directory is available of your database. So it is available under PG data location, which is nothing but user home directory. Under that, okay, so portion directory, under that data directory, under that you'll have this file actually. What is the name? PostgreSQL.conf file. Postgre.sql is a text file. We can use text editor to edit and do the necessary settings. So for example, we have learned about shared buffers, update it. But what are the changes you do is not dynamically read by Postgres. You have to restart your service. Means whenever you update a parameter in your Postgres, you must ensure that so your service is going to read that file, because it is going to read that file only during starting of your service. If you want to make it to read, so you have to restart it actually. Means you have to reload your service. So then it is going to read the configuration file. Default path for your configuration file is PG data. Default name is PostgreSQL.conf, meant for custom configurations. So we are going to use configuration files or configuration parameters for defining the values for your parameters. For example, shared buffers. So we can set a value based on our requirement. So there is the example. So this is the configuration file. So four most important files. Data file. In fact, we are not going to learn data files individually, because when we say data file is a location for your database. So slightly will change that when we learn about tablespace. So as of now is a location for your database. We can define a location. Wall files are for maintaining the changes. Archive files are nothing but copying the content of your wall file segment wise into a ready file. Then it is going to convert it into a done file. Configuration file is for custom configuration. Present under default location is PG data. Okay, so under that name is PostgreSQL.conf is the name. So initially when we implement, we'll go for everything default configuration. As we progress, okay, we'll also start customizing and using specific parameters also or specific features. So this is about some of the important components of your database architecture wise. So we have learned about background processors first, then memory structures, then files. So about objects, once we start doing practicals, within that only I'll keep showing them also. So we'll see concepts of those objects also as we progress with practical topics. So this is about Postgres architecture.